Hey everyone, thank you so much for joining this talk. My name is Jad Joubran, and I'm going to present to you the secrets of native-like progressive web apps. Throughout this talk, you can post your questions on the live chat. I'm going to be checking it every once in a while. So right now I have the presentation on full screen, so I cannot see the chat, but I'll try to take a pause every couple of chapters. And we're also going to have a dedicated Q&A session. Before I start with the talk, I just want to cover some tips from GDG Mina. So first, you can subscribe to the YouTube channel. This is the link over here, and you can click on subscribe to be notified. And then, if you want to get all of these links, by the way, will be posted on the live chat. But if you want to get the steps if you want to get the attendance certificate, then this is the link for it. And then they also have a challenge for you, which you can also find over here. And then there's a gift box full of goodies or Google Home Mini. And if you're interested in Flutters, this is the schedule for Flutter days. And this one too. And finally, this is the schedule for today. So I think this is the last talk for today, Secrets of Native-like Progressive Web Apps. Let's see if we got any questions before starting. All right, should be good. Cool. So when you're developing a progressive web app, I think there's three main pillars that you should always be considering. And the first one is the user interface. So that's like how the buttons look like, making it look like a mobile app. So trying to use the same user interface like a mobile app. And then the user experience, which you're going to see throughout this talk, goes really hand in hand with performance. So UX and performance, they go really well hand in hand. And finally, reliability. So by that, I mean, if you're using a progressive web app and you walk out of the house, you go to the metro, you take the bus, can you continue on doing what you were planning to do? Or will the app just show you the offline page? So it doesn't necessarily have to function 100% as if it was online, but at least give you some kind of offline experience and be reliable, be always fast, always expect it to work. And when talking about progressive web apps, you will often find not one specific explanation or definition. And I like to show you the one I believe in. And it's also categorizing progressive web app and successful progressive web apps. And I think successful progressive web apps are those apps that are built with web technologies. So that's HTML, CSS, and JavaScript, but that also satisfy and exceed user expectation. So it's really about thinking about the user and going a step ahead to try and make sure that your app is going to be used by your users and that your users will absolutely love it. So before we start with the first step, any questions? No questions. All right. So the first recommendation that I have for you is to design and build an app shell. And this used to be my cat, and he's sitting in an app shell perfectly. So you might be wondering what an app shell is. And for that, I'm going to show you a native app, which is Twitter. This is the Twitter native app on Android. And I'm going to play the video again. When you click on the icon, you're going to see the app shell. This is the app shell. It's the screen you're going to see a fraction of a second before the content loads. And this app shell contains several elements. For example, the nav bar, the floating action button, and the tab bar. You don't have to have all of them. It depends on your design. It depends on if your app it will be nice to have an app shell, but a lot of apps, it will be nice to have an app shell. And then let's see what happens when the content loads. So the content just loads inside of the app shell. And this is a pattern you're going to see a lot on your Android and iOS phones. Almost no matter any app you open, you're going to see that even if it's for a split of a second, there's going to be an app shell. So this is a pattern you can apply for progressive web apps. And in fact, a lot of progressive web apps have implemented it already. For example, the Flipkart PWA, you can see it on the left, but also the Twitter progressive web app. So this one on the right is the progressive web app. This is an old screenshot. I think they have the tab bar at the bottom now. Now you might be wondering, how do we build an app shell on the web? Well, you can build an app shell by inlining the HTML and CSS and JavaScript necessary to render this app shell. So for example, in this example, we have the header, or we have the navbar, and we have the loader, and then we have the search box. So you just write all the HTML, CSS, and JavaScript necessary to render this, and you inline it. By inlining it, you're giving it full priority to the browser. You're telling it, this is the most important thing you should render ASAP. Now, of course, this comes with a caveat, which is if you're inlining everything on the page, then you're telling the browser everything is very important, which of course doesn't work that way. This is going to slow down your page. So make sure to have some limits. I like to go with 40 kilobytes as a limit, maybe even less if you can. And that way you can almost guarantee that your website will not take more than 1 second when loading on a slow connection, such as fast 3G, because fast 3G is relatively a slow connection. And if you're using Workbox, or if you want to generate a service worker, so Workbox is a tool that helps you generate service workers, and this service worker is going to cache the app shell. And this is a sample code that you can use in Webpack to cache the app shell. And by caching the app shell, you're going to be able to render this app shell immediately, almost instantly, every single time the user opens the app. Of course, after it has been cached. Because the first time the user lands on your website, this is when there's nothing in the cache. You're going to install the service worker. And then later on, once you have that in a cache, the next time you open the app, every single time, the app shell is going to load instantly. It's going to be super fast. And even if you're offline, and this is the benefit of building the app shell. So you're kind of giving the same native experience to the user. Any questions? No. All right. Now on to section number 2, and that's really building on top of the first section. A lot of progressive web apps build an app shell and stop there, but you can realize that you can take this a step further. You can build an advanced app shell. And to show you an example of what I mean, let's take a look at this native app. So this is the Philips Hue Light app. I'm gonna play the video again. Nothing really fancy about it, but it's very easy to use. And the reason why it's very easy to use is because of this tab bar at the bottom. So this tab bar has a lot of benefits. You see it in a lot of apps, not all of the apps, so it's not really a requirement. It depends on what you're trying to build, but it greatly simplifies the navigational user experience. And that's a fancy way to say that the user will easily know that there's 4 main pages: home, routines, explore, and settings. And then they can go through them by just clicking on those tabs. They don't have to look for things on the top level. Now, of course, the settings will have several sub-pages, but mentally you think, I need to go to change my email. So that's most likely going to be in the settings, and then you click on the settings. I don't know if you notice, it's also conveniently positioned at the bottom. This makes it much easier for you to reach on handheld devices. So it's at the bottom, you can easily reach it with your thumb. And lastly, it makes it look like a native app. That's because there's so many native apps that have this tab bar. By just building a tab bar that looks good and has a good user experience, your PWA is going to look like a native app. And you might be, and I think that the reason why we weren't building advanced app shells is because we were thinking that this is not possible today. How can we build a tab bar? But in fact, if you pay attention to a couple of things, these are some of the tips that I have for you. You can really build an app shell that is really fast, really snappy, and easy to use. Some general recommendation is try to never animate left, width, and height. Stick to animating transform and opacity. That way you can have really smooth transitions even on an old device. Also avoid expensive work on the main thread while doing some animation. So if you're doing a full page animation or the tab bar animation, try not to do anything like dispatching fetch requests or maybe even sending analytics. Try to delay all of these until the animation has ended. And then finally, make sure to test on several devices. So our laptops are overpowered compared to our phones. So if something is fast on your laptop, it doesn't necessarily mean it's fast on your phone. But also if you have a decent phone, like an iPhone or a Pixel or the newest Samsung, make sure to test on middle range devices or low end devices, because then you will also see a difference in performance. Now let's take a look at another example of an app shell, and this one of an advanced app shell, and this one is using the tab bar. So let's go back. This is a screenshot of a banking app, and you click on events. It's going to slide to the events page, and then you click on one of the payments, and it shows you a model. But in fact, this is a progressive web app. So this is something I built as a demo. The app is not real, as in it's not really talking to a banking API, but this is a demo that I built to show that I actually cloned a native app in terms of user experience. And this really shows you that if you invest in user experience and try to build something that looks like a native app, you can really achieve great results. And let's take a look at this example where you can flick through the screens and flick right, flick left, and then you will switch to the other page. You can probably tell this is a progressive web app because I didn't spend a lot of time on the design. It was just a quick demo. But what's really exciting about this one is that this is mostly 2 lines of CSS because of the new scroll snap API. So on the container, you set scroll snap type X, so on the X axis, mandatory. So you're going to force it to snap when the user releases their finger. And then for the children, you give it a scroll snap align start or center, or I think end. In this case, it doesn't really matter because every child is taking up 100% of the viewport width. But this is it, really, just 2 lines of code, and then you have this snapping behavior. I do use a couple of JavaScript to update the title, but other than that, it's very easy to work with these things nowadays. Now, the third tip that I have for you is to reduce your JavaScript footprint. Because the more JavaScript you're going to add in the beginning or when the user clicks on something, the more the browser is going to have to do, the more your app feels sluggish, and the less native it feels like. So I have a couple of tips. There's a lot of things we can do in performance here. I just try to summarize the ones that will give you a lot of benefits while not working a lot for them. So the first thing is using the module, no module split. So use script type module for all the new modern browsers. So all the new modern browsers will read script type module, and then this allows you to ship JavaScript without passing it through Babel. So then if you write a class, it's just going to be a class. If you write a template string, it's going to be a template string. You don't have to pass it through Babel, because you can write ES 2015 or ES 2015 plus, and all these browsers will understand it. And now for all the other older browsers, so for Internet Explorer, use the script type, the script no module attribute. And this is on purpose ignored by modern browsers. So in that way, even though you have 2 scripts, only one of them will be executed. Type module for the new browsers, no module for the old ones. And this is where you can pass your code through Babel and then make sure everything works on IE. If you don't have to worry about IE, then just use script type module, and then you're shipping class as a class. And that has 2 major benefits. One is you're going to shave a couple of kilobytes of your JavaScript, because when you pass it through Babel, things will become bigger, because a class becomes a function or a generator function, I'm not sure, and then it becomes much bigger. But also, you'll be able to use the modern optimizations that every browser has. So for example, V8 has optimizations for example, for class, and same for SpiderMonkey and all the other engines. Another tip, this is actually not the tip, this is what we used to do, is where you have your app.JavaScript, and you have the home, the vendor, settings, help, and payment. You have all of your JavaScript in just one file, and that file is going to be quite big. Instead, what you want to do is you want to split it using code splitting. So you create a bundle of the app.JavaScript which contains the minimum requirements, like the home.js and the vendor.js. And then, only when the user goes to the settings page, this is when you request the settings.js. If they go to the help, you request the help.js. If they never go to payment.js, you never request it. So you're always just asking for the JavaScript when you know the user is going to use it. And this has a benefit of not shipping a lot of JavaScript, so then the phone or device has so much more memory, is able to respond to the user's event much easier than before. To work with that's actually very easy. If you're using Webpack or Parcel, and this also works natively in the browsers now, you can write an import, but as a function. When you write it as a function, it's different than the import without a function. When you write it import with a function, this is going to import it at runtime. So when JavaScript is running in the browser, it's going to see import settings. It's going to send a fetch request or network request to get the settings.js. And this is going to give you a promise. So then you can resolve it. And you have the module over there. You can call the default exported method or whatever methods you've been exporting. Now, this is very easy to write. However, it's also very easy to mess up the UI, the user interface. This is why I have a couple of tips for you here. And the first one is, if you're loading the screen, if you're dynamically loading the settings page and then the user just staring at a blank screen, you want to make sure to show a loader. You want to give feedback to the user that this page is loading. And the reason why I said these are easy to mess up is because when you're developing, this import settings it's gonna load instantly on your computer. But when you deploy your code, this is where it's gonna be slower. You can even take it a step further. And if you have to load a large chunk, for example, in one of my projects, I had to load a chunk of 4 megabytes of JavaScript. There's really no way around it. But what you can do is after 3 seconds, if it's still loading, so if the import hasn't resolved yet, you can show a message saying you change the loading into still loading. And this gives more comfort to the user that we know your app, we know the app is not broken, it's just a connection thing. It's going to work eventually, give us more time. And finally, you can show a retry button for critical chunks. So for example, sometimes you try to load the sidebar, but the sidebar doesn't work. And then it's fine if it doesn't load. It's not a big deal, maybe. But sometimes you try to load the settings page, but if the settings page doesn't work, then the app is broken. So you can show a retry button that allows the user to try again. That's going to be useful if they go out of the house and they switch connections and the fetch request fails. Any questions? Why is the app shell good for offline access in case my app only works online? So good question. In case your app only works online, you can decide not to do an app shell. It's not really a requirement. It's just a tip. But what you can do is you can still have the app shell and then show a button or a message that says, it seems that you're offline right now, and then you can retry later on. So this is the minimum that you can do. But again, these are not requirements. These are recommendations. And no, I take back the word recommendations. It depends on what you're building. But if you really want to make it look like a native app, then it's probably going to be nice to have an app shell. All right, so that's the only question. Now, number 4. So don't be like the cat and take forever to respond. Try to react with fast interactions, almost instant interactions if possible. So I can show you an example here. And we know this from physics, where every action needs a reaction. And that's especially true for user interface. So if you have a button, the user clicks on the button, you want to give them feedback immediately that we received your click and we're going to work on it. And you can do that with a ripple effect. You can do that with a hover or an active, sorry, not a hover, but an active style. You can maybe start showing a loader immediately. And what I want to show you here is a tip that can really help with a lot of performance issues, and that's request idle callback. This is a new web API, and it allows you to defer work that is not necessarily critical. So I'll give you an example. You launch your app and you have a button that says start, and then you click on start, and this is where you send your browser 10,000 lines of code. So maybe you're initializing a plugin, you're sending a couple of fetch requests, sending a link to analytics, loading the chat, etc. And then the browser has to do everything with just this one button click. Instead, what you can do is you can find the smallest chunks of work that are not necessarily, that don't necessarily need to run immediately, and you wrap them with request idle callback. What what the browser can do now is it knows that these chunks of work can be delayed until the browser has more time and space, so more memory and CPU to deal with them. And it's going to try and run them in small chunks of 15 to 50 milliseconds, so 15 to 50. And yeah, then it's going to run them later on. It may run, it will run them like as soon as the browser has time. So you're spreading them across more time. And think about like sending analytics request. It's not urgent. It's not a critical request that really needs to happen when the user clicks. When the user clicks, you probably need to do a couple of things that, like rendering the DOM or sending fetch requests. These are the most important things. A couple of caveats though. This isn't implemented on Safari yet, but there's a very tiny polyfill that you can use. So you can include the polyfill for Safari. And it is generally a tricky web API to work with. I've personally screwed it up several times, so make sure to measure the before and after using it just to see if this is really solving your issue or not. And also, if you request idle callback and then pass a big chunk of work, that's going to slow down your page again, because the browser has only 50 milliseconds. And if you exceed that 50 milliseconds, then you're going to go over frame budget, and that's also going to slow things down. So keep in mind, request idle callback, smallest possible task, and then non-critical. You can have several one of them, and this is going to make the 60 frames per second easier to hit. Now, let's take a look at the app. This app, the calendar app. So you click on book flight, you get an animation, and it opens in full screen. I don't know if you're familiar with this app on Android, but this is actually another progressive web app. It's also another small demo that I built. So again, it doesn't function beyond what you see. You cannot scroll between pages or add a new event, but it just shows you that if you invest a lot in user experience and then try to have this native look and feel, you can really achieve that. And this is an example where you can use request idle callback to defer all the non-critical work, because when I click on book flight or prepare dinner, the most important thing is to show the ripple and then show the animation, show the data, and then later on you can deal with the analytics or all the things that are not important. Number 5, make it work offline. This is also a recommendation, depends on what you're building. And this talk doesn't really go a lot in depth on how to make it work offline. I just have 2 or 3 tips that I want to give to you. If you're using Workbox and you register a route, so here you're telling Workbox anything that's coming from the API, I want to use the network first strategy, which means I'm going to go to the network and then get the response back. If there's no network connection, I'll get it from the cache. This is great, but to avoid a common, not very common, but to avoid an issue that happens sometimes, try to always pass the network timeout seconds. And that means if you go to the network and it's been 5 seconds and I'm not getting any response, consider it failed and fall back to the cache. So this prevents you from having a network request that's loading for over a minute. So we call this scenario li-fi. So like Wi-Fi, but lying, li-fi. And that's when your computer or phone thinks it has Wi-Fi, but it really doesn't have Wi-Fi. But it thinks it has Wi-Fi because it's connected to the router, but the router doesn't have Wi-Fi. And the operating system doesn't know that. So it's going to keep waiting for 60 seconds, sometimes 120 seconds before it fails. So this essentially allows it to fail earlier and then fall back to the cache. And also you want to be mindful of the user storage. So if you're caching images, video files, or my tip for you is just always try to have the expiration plugin if you can expire the things that you're caching. And you can specify a combination of max age entries and or max age seconds. So if you have 50, and you add the 51st, it's gonna expire the oldest one. And max age seconds is saying if this has been in the cache more than X seconds, then remove it. And the purge on quota error is interesting. It's when you're whole device is out of storage, you can tell it, this is okay, this can be removed immediately, but try to keep these other things if possible. It's not a guarantee, it's more like a prioritization of what can be deleted and cannot be deleted in case your system is under storage pressure. Let's see if we have any questions. All right, all good. Memory cache, does the limitation to like... I don't get the question. Can you rephrase, please? What's n/? Okay, I'm going to continue with the slides and I'll see your question in a bit. Number 6, increase the add to home screen conversion. So this is a tip that is based on an API which allows you to show a custom button, and then from that button you can click on it and ask the user to add the app or add the PWA to their home screen. What I want to recommend here is to not show this in the beginning. The web is already unfortunately annoying with all the pop-ups, all the GDPR cookies, all the cookie dialogues, and we don't really want another one saying add us to the home screen. And in fact, you can really increase your conversion by delaying this prompt until the user becomes familiar with your app. So let me show you an example. This is Flashcards app that I built for one of my courses, and this is the landing page. The user lands here, and I don't ask them to add it to the home screen because they have no idea what the app does. But now look, when they click on Start Flashcards, they get the questions, and these questions are related to a course they're taking in parallel. And then when they go through the questions, by the time they've reached the 10th question, they have an idea how this app works and how it relates to the course. So then this is where you tell them, hey, practice daily, add to home screen, you click, and this is the native install banner. And when you click add, there you go. You're gonna have the app added to the home screen. Now, note that this app install banner only works on Chromium-based browsers. So that's going to be Chrome, Opera, and Edge, the new Edge. But unfortunately, it doesn't work on Firefox and Safari. And this is the code for it. You listen to the before install prompt event. And then when you're ready on a user gesture, on a click gesture, you call the event.userChoice, and that's going to resolve with a promise. And then if you log the result.outcome, you're going to see if it was accepted or dismissed. And finally, make sure to build a smooth update process. So because you're building a progressive web app, you're going to have to think about how to tell the user that there's a new update. Kind of how, like, with a native app, if you go to the store, there's going to be a newer version. Or sometimes the app tells you there's a newer version. But for that, I need to explain to you first how the 4 steps that the service worker goes through when being installed, when being activated. The first one is getting parsed. This is where the browser makes sure that there are no syntax errors. And then it gets installed. So the service worker gets installed, but it's also in a waiting phase. It's waiting while it's checking and asking the browser, hey browser, is there any other service worker installed on this current domain? And the answer here is no. So it's going to be activated. And when it's activated, it's going to be controlling the current page, which means all network requests will go through this activated service worker until it reaches a point and it's redundant. Now, let's say that this is the 4th service worker that we have in our app, and we want to push a new service worker. So for example, v5. We don't really have this versioning, but I'm trying to show you that this is v4 and this is v5. This is how you upgrade service workers. So the previous one is running, v4 is running, and then the new one, v5, will get parsed. It will also get installed in parallel. But in the waiting phase, it asks the browser if there's another service worker that is active, and yes, there is. It cannot activate. You cannot have 2 active service workers at the same time. And this is where you as a developer need to call the skip waiting method. And by calling the skip waiting method, you're telling it that I'm done with the old service worker and I'm ready to activate the new one. which is going to move the previous one and make it redundant. I'm going to show you the code for this one in a bit. Now, as for the UI, you can show a toast, you can show a modal, but these things generally tend to be a little bit annoying because it's really taking a lot of real estate from the screen. It's also like distracting your users. What I would recommend, but again, depends on your use case, is to go with the update dot. And that's the first time you see the screen, so you probably cannot see where the update dot is, but there you go. This is it here. This dot over here, for users who've already been on this app, they will know that there's something new. And then they will click on it and they will see the highlighted menu item is update app. So this is a subtle way to tell users that there's something new you can update, but it's not urgent, because most of the times you don't really want to bug users and update all this every single time. And this is, I think this is a nice way to do it. As for the code, it's a little bit complicated because some of it has to go in the service worker.js file. So this one over here, and some other code, the rest has to go in your index.js or your at the window, more or less. Now let's have time for questions before I do the closing. For example, so I think Hazem is asking if there are limitations, size limitations. Okay, so the question is if there are size limitations. There are size limitations for the things you want to cache in the browser. And I think for Chrome is around, I don't really remember the exact number, but maybe as big as 50% of the entire computer, entire device. For Safari, as far as I remember, it was 50 megabyte. So every browser has their own limit. There's an article on web.Dev where you can check that. But also there's an API, I don't know which browser supports it, where you can check how much storage space you have left. So that's going to be useful if you're caching videos, audios, or large files. Any other questions? All right, let's wait a few seconds just in case. Thank you, my pleasure. I still have to do the closing. Let's see if there are any questions. All right, I guess not. So I'm gonna carry on with the closing. So as you can see from this presentation that it's all about the attention to detail. A lot of the times when we build for the web, we don't necessarily hire a UX designer because it's just the web. We can slam a couple of buttons together and we have a website. But in fact, this is something that has challenged me personally in one of the apps that I've built. And this is one of my online courses. And this is how it was before writing these slides. I wanted to make it responsive for mobile, so I took the display grid and I made a display block, so then everything was underneath each other. And it became responsive. I don't think you can argue with that. It is responsive, but is it really mobile friendly? And this is where I tried and challenge myself and implement some of the tips in this talk. And this is the end result, where you have a tab experience. It's clear what you need to do. You have the instructions, the code, the tests. The confetti was in both of them, but also if you see the attention to detail, the number of tests passing and not passing is shown in the tab bar. And you can also slide between these pages. And it's far from done. I'm not saying this is perfect, but you can see the kind of experience when you really think about the UX. And also what's interesting about this is that it took me twice the amount of time to think, experiment, and design the UX than actually implementing it with the code. And I think this is where we need to think more, have more time for UX, and maybe hire the best UX people for mobile. So I want to leave you with a final thought, which is let's go ahead and build progressive web apps our users will absolutely love. You can get the slides from bit.ly/mina-dd-pwa. And you can follow me on Twitter @Joubran. Jad, Joubran, Jad. And I think those links will be shared on the live chat if possible. And there's a new question. Is there good tips to prove the performance of my app on various... do you mean like testing the performance of your app on server connection speeds? Thanks for sharing the slides link. Yeah, you can use Chrome DevTools for that. Even on your phone, if you plug the inspector and then go to Chrome://inspect, then you can enable 3G throttling, slow 3G, fast 3G, and then online. And you can also do that on your laptop or desktop as well. All right, so that was it for me. Thank you everyone for joining. I hope you enjoyed it. You can ask me questions on Twitter. I will answer all of them. And yeah, thank you very much. Have a nice evening.